last week when I was working on the steampunk bracer piece, I kept taking pictures on Instagram and showing you the progress along the way, but never really said what I was working on from the start. So this week I'm going to take a different approach. I'm working on a new project this week, which is an L panel animation. If you're wondering what L is, it's EL, or electroluminescent. I have a piece of L wire here. It's basically, if you put a current to it, it lights up. Some call it cool neon. I like it sort of as a lighting effect. I'll get into some of the issues that I have with it as we go through this, but what I'm doing isn't actually L wire. What I found, there's a little blinking effect it does, that's kind of nice too. Anyway, were these L panels. So basically it's a square panel that has the electroluminescence stuff inside of it that gets a current from here. When the current comes on, it lights up. The nice thing about these is you can cut them into just about any shape that you want to put them in, and as long as the edges are taped and the sensor is touching where it comes in, they'll light up. I have a number of these that I'm building into an animated sign. So there'll be 7 of them arrayed. Here, let me show this again. So think of this as a ball. What I really want to do is have a string on a ball. And then when I begin to swing the string on the ball, it begins to go side to side, one there, one there, one there, one there, one there, one there. So there's 7 in all, so it'll start to swing and swing, swing and swing, swing and swing. So that's the general premise. I have 7 points. Now, the Arduino piece that I'm using actually has 8 ports on it, but I decided to go with 7 in this animation because it seemed like it was important to have a bottom point, because it just needs to look like this pendulum thing that I'm making just is resting at some point and not just sort of hanging cocked to one side. So it had to have a center bottom point. So I only went with 7 rather than 8, but that's okay. It still gives a really sort of nice idea of this animation. So some of the other parts that I'll be including in this piece this week are, again, an Arduino Uno and an EL. It's called the El Escudo Dos from SparkFun. It basically allows you to attach 8 EL components to it. The thing about EL wire, and I talked about this earlier, it being a little bit problematic, is it's really high voltage. It's, well, not high voltage, but it's 12 volts, so it can zap you. And it takes a lot of inverters and powers to run a very small sort of sign. So one of the reasons I went from the L wire to these L panels is you get a little bit more bang from the buck in terms of how much it lights up. So months ago I got this shield from SparkFun, and shields are boards that are extensions that can be plugged in on top of an Arduino PCB. So essentially that's what it is. You have your stackable headers on both sides that allow them to be sort of extension cords. These are some controllers coming out of this that I might be using later. I soldered this together and put this together, like I said, a couple of months ago, and then it sat on the workbench waiting its turn. So I have an Arduino, a shield, 7 EL panels. What else do I have as part of this? You need a 12 volt power source, so I'm just going to go ahead and plug that into the shield. Again, 12 volts. I also got a 12 volt inverter so that I can take the 110 down to output of 12 volts at 5 amps DC. So it's a pretty big piece of power. I'm going to plug a couple of these EL panels in here just so that you can see what they look like. I've already put a program in here that plays them at a sort of constant sequence. Eventually we're going to try and program it so that it takes on real pendular momentum, but I'm going to plug enough in here now so that you can at least see it. Set these other guys aside. just felt the plastic coming off of one of those, and that's where you get the real zap, according to Kip, is when you put your finger down. I haven't had the pleasure yet. He has. So, anyway, going back to this. So, 12 volt, 12 volt, and then I also have to plug in a 5 volt into the Arduino, which again, and then you begin to see them light up. Again, it's only 3 points in the 7-point animation that I'm showing you, and it's not that exciting right now, but then again, it's the first day of the project. So let's go back to the drawing board here for just 1 second. 7 positions, like I said. Eventually, what I'm doing is taking a piece of MDF that I found in the basement from some project that Jeff left over from years ago. It'll be shaped something like this. This will be about just under 4 feet. The Arduino unit will be mounted here with a big plastic globe over the top of it so that it's so that it's dust resistant. Each one of the EL panels will have one of these other plastic domes in front of it. I've been taking steel wool and sanding them out on the inside so they're a little bit translucent. That makes it so when you look at it from the side with the EL panel, it looks more like a globe and less just like a flat sheet. It's just to give it more dimensionality by putting these in front of the red flat panels. So what else do we got going here? The only other parts that are missing would be 2 red potentiometers that go right there and there. Now, what do they do? So let's go to here. So I have these 2 chicken head potentiometers. One of them without it. And there's the chicken head. You know, an analog knob, a second analog knob. One of these will control the height of the swing, and one of them will control the rate of the swing. Now, when I say height, it's just like, does it 1 2 1 2 back and forth, or is it 1 2 3 1 2 3 1 2 3, or is it all of them? And then the rate, is it, you know, slow like a Foucault's pendulum, or is it, you know, excited like a Greek grandpa's worry beads on the ferry to Mykonos or something? You get the idea. So you have height, how many, and rate, how fast. So, am I missing anything? Got all of the power sources. Getting all the power sources for this together, like I said, was the hardest part, because you have to get one for the Arduino, the power source for the shield, and then the 12 volt inverter for the power source that goes into the shield. Again, a lot of power going to this for a little bit. It'll all be in one contained unit. Like I said, I'm making it in a big piece of MDF. Lots of routing, cutting, trying to shape these pieces through aperture holes this week. So stand by for the pictures. Follow me on Instagram, Mokendo, and you can see the progress. Check in later.